Good afternoon and welcome to Carlam Cymru revision sessions. This session will focus on Maths AS level and will be presented by Mr Grant Mackenzie from Porthcawl Comprehensive School. The session will last around 45 minutes, where the teacher will go through the relevant subject content. If you have any questions, please use the question and answer section and we will endeavour to answer your question during the session. The sessions will be recorded, with a recording and any relevant resources uploaded to the e-sgol website in the Carlam Cymru area. Thank you.
Okay, thank you very much. So over the course of the next 4 weeks, I'm going to be taking different sort of parts of the AS level, and today we're going to go through trigonometry. If I sort of draw your attention to this page, really this here is the only thing which is new to you. So you've been given the area of a triangle, you've been given the cosine rule, the sine rule, and also the trigonometric graphs. So the sine, cos, and tan. Over here, we've got sine squared plus cos squared is equal to 1, and then tan theta is equal to sine theta over cos theta. I'm going to concentrate on the first 4 or 5 questions using the sine cosine rule, and then I'm going to go and do the sort of the new material as well. With the sine and cosine rule, I am going to sort of put in more of the complex questions that you would receive, but I mean, it's also good to go back over your GCSE ones just so that you can sort of familiarize yourself with how to use the formula and what you need to do. So if we go to the first question, it is. So as you can see here, the diagram above shows the triangle ABC with AB equals 6, BC equals 4, and CA is equal to 5. It's a bog standard triangle, you would have seen it before. The sort of notation and everything else is a little bit different. So we need to show that cos A is equal to 3 over 4. Cos A is located here, and with that, we have our sort of, if you can remember from congruence, the SAS. So the side angle side, we're going to be using the cosine rule. So if we remembering that capital A stands for the angle, and then opposite, this is going to be our little a here, opposite B, this is going to be B here, and opposite C, this is going to be here. So using the formula, A squared equals B squared plus C squared minus 2BC cos of the angle A. I know that various different maths teachers, the way they've done it, might have rearranged it. I prefer to put the numbers in and then rearrange at the end. Or if you want to, you can go straight into. So A squared is equal to 4. So we're going to have 4 squared equals 5 squared plus 6 squared minus 2 times 5 times 6 cos of the angle A. I have done a lot of the sort of calculations before this just because it sort of saves time as I'm going through it, so I can get through more of the complicated ones. We then have 16 is equal to 25 plus 36, and that is minus 60 cos A. Rearranging this, we have 60 cos A is equal to 61 minus 16, and therefore cos A equals 45 over 60, which is 3/4. Nothing wrong with putting a QED, the Latin for thus proven. So we've now done that part. Hence or otherwise, find the exact value of sine A. They do like to use that word hence, meaning that from what you've done in part A, now you can show it in part B. There are other ways of doing it, but you've probably come halfway there already, so you might as well sort of carry on this thread. If you remember from GCSE with a right angle triangle, if we say this is A instead of theta, for cos it would be the adjacent, which is this one here, which is 3, over the hypotenuse. To work out sine, so this would be sine A, it is the opposite over the hypotenuse. While using this being a right angle triangle, Pythagoras, we can work out the missing value of x. So it would be, in simplest terms, x equals the square root of 4 squared minus 3 squared. Again, it's a sort of simple equation of Pythagoras. So that's going to be 16 minus 9. So that is going to be equal to root 7. Therefore, sine A is going to be opposite, which is root 7, over the hypotenuse, which is 4. And that would be the answer, because it just asks for the exact value of sine. We wouldn't simplify that down and put it as a decimal, because the exact value means that you leave it as a surd or you leave it as a fraction. The next question is again a more of a problem solving question for using the sine and cosine rule. So we have some walkers see a tower, t in the distance, and want to know how far away it is. They take a bearing from a point A and they walk 50 meters in a straight line before taking another bearing at point B. They find that the angle TAB is 70 degrees and the angle TBA is 107 degrees. Well, adding those two together, you get 177. So the missing angle at T is equal to 3. I'm just going to put that in there now. Angles in triangle at 180. Find the distance of the tower from A. What I'm hoping you can see, this is pairs. So we need to find the distance of the tower from A. So we're looking for, if I label the diagram again, that is lower t, lowercase b, lowercase a. So we're actually looking for the value of b, because that would be the distance from the tower from A. So we haven't got the SAS here, side angle sine. What we've got is, this is going to be the sine rule. B is what we're trying to work out. So we put b over sine b. We have that angle, and the angle that links and the side that links everything is t. So it's going to be t over sine t. B is over sine 107 equals t, which is 50 over sine 3. Rearranging this, b is equal to 50 times sine of 107 over sine of 3. As I said, I've worked out most of the calculations beforehand because of the fact that where are you gone? Oh yeah, down the bottom. Because of the fact that I don't want to waste any time. I'd rather go through the questions. This was 903.6 meters. So we've done the first part. Nothing new to you there, but now it gets a little bit more complicated. So they continue walking along the same distance for another 100 meters to a point C. Let's draw that in. So they've continued on this line to this point here, which we're going to mark as C. So the total distance now is 150 meters. So the AC is 150 meters. What is the distance of the tower from C? So here, we know, if I cross B off here, we know that this is 913.6 meters. We know the angle there, 70, hasn't changed, and we know this length here, which is 150. So we do have that sort of SAS, where we have this side, the angle in between, and that side. I know the diagram is getting a little bit sort of cluttered, but it will sort of make sense when you sort of look through it. So as we're going that way and that way, we can now work out what the distance from the tower of C is using the cosine rule. Doing so, we're going to label it as a squared equals, in this case, it's going to be c squared, and then it's going to be plus t squared 2a minus 2ct cos of the angle A. Putting all this information in, c is going to be 913.6 squared plus the t squared is going to be 150 squared minus 2 times 913.6, 150 cos of the angle at 70. A squared is equal to 763424.08. So A is equal to the square root of all of this. A is equal to 873.7. And the last question, find the shortest distance of the walkers from the tower as they walk from A to C. So we haven't been given any information, but if you remember that the shortest distance between 2 points is a straight line. So this straight line here would mean that that is perpendicular. So if I redraw that, where we have the 913.6, so if I go over the page, we have a perpendicular from the tower. So there's your T, there's your A. That's a perpendicular, so it's 90 degrees. That was 70. This was 913.6. And it was asking us to work out X, which is the shortest distance from A. And then if I put C over here, like so. Well, again, this is just going to be SOHCAHTOA, where you have this being the opposite here at X, which is what you're trying to find out, the hypotenuse. So it's going to be sine A equals the opposite over the hypotenuse, 13.6. So then X is equal to 913.6 times sine of 70. This will then give us 858.5 meters. And seen as it is the shortest distance is going to have to be less than what we had before, which was 873.7. That's done. We can move on to the sort of next question. Next, this is from a WJC. I've taken a range of questions from different exam boards simply because I've tried to find the most complex ones. That way then you can see, and maybe, as I said, if you want to pause the questions as you're going through it, you can have a look at what you need to do, and then from there, you can work out as best as you possibly can. Right, so here we have the triangle ABC is such that AC is 16, AB is 25, ABC is 32. Find the two possible values for the area of the triangle. First thing I would sort of suggest doing is to sketch it. It doesn't have to be perfect, it just needs to be a triangle. If I stick this as A, this one is B, and then this one is C. So we're told that AC is equal to 16 centimeters. We're told that AB is equal to 25. And again, if I put centimeters, we're also told that ABC is equal to 32. Right, we can't use we're looking for find two possible values of the area of the triangle. Well, if we're looking for the area of the triangle, we need that SAS, where we have the side angle side. We haven't got that because, sorry, wrong one. We haven't got that. What we have got, we've got this side and we've got this side, but I need to work out that angle there before I can do anything else. In doing so, I'm going to have to use the sine rule to work out C. Once I've used the sine rule to work out C, I can use angles in a triangle that add up to 180. But not only that, notice what it says. There are two possible values. Well, that's meaning that we're going to use either cast or the sine graph to work out what the two potential values are. Now, I know that a lot of you would use cast, but I'm going to be using the graph version. So if you can do exactly the same using the cast diagram to make sure that you can show where those values are coming from. So you need to work out C. So it's going to be sine C over C equals sine B over B. Sine C, that's what we're trying to work out. So sine C over 25 is equal to sine of 32 over 16. That rearranges to sine C equals 25 sine 32 over 16. So C is equal to sine to the minus 1 of that answer, which I believe was 0.827. That is an 8.827, which is equal to 55.9. As it said, there are two possible answers, so therefore there's going to be two possible values for that C. How I would do it is I would draw a sine graph down. 0.8 is approximately there. There is 90 degrees. There is 180 degrees. The distance from where it cuts the axis to there, that distance there is going to be 55.9. So using your sine graph, the distance from 180 to where it cuts, so the distance there is also going to be 55.9. So my other possible answer would be 180 minus 55.9, which would give me 124.1. That being said, I now need to find my angle at A. Adding up, let's do, if we call this one P1, so not P1, if we call this one A1, and then we call this one A2. So to calculate A1, I do apologize, no, I won't call it that. We'll call it C1 and C1. It's easier that way. So we call this C1, call this one C2. We can then say that A1, which is the first angle, is going to be 180 minus then 32 plus 55.9. So this is then going to equal 92.1. Then A2, which is the other potential angle, would be 180 minus 32 plus 124.1, and that would be equal to 23.9. So we've got our two potential angles for A. Now we need to work out our area. So if we go area 1, let's write that as area, too many letters going on. So if we write that as area 1, using the sine rule, we have got a half multiplied by 25 times 16 times sine of 92.1, which would give us an area of 199.9 centimeters squared. Our area 2, using the second angle, would be a half times 25 times 16 times sine of 23.9, which would give us an area of 81 centimeters squared. So that would be a 5 marker. I would probably say you're going to be using 2 marks to work out the 55.9, third mark for 124.1, and then I would say for each of the correct areas would be a 1 mark each. There's quite a lot of work to do at the start of this, and then obviously the reward will come when you get the 2 marks at the end. Okay, last one I promise on sort of the cosine and the sine rule. It's more because this one was based with algebra. I like the last question because you have to show using obviously the sine graph that there were 2 potential values for the angle. So again, it's normal triangle. The diagram shows the triangle ABC with AB equal to X, AC equal to Y, and the angle BAC equals 60 is given that the area of the triangle is X plus Y in brackets times root 3. Show that 4X plus 4Y is equal to XY. Well, looking at the information, the only thing that I know is I know that's the area of the triangle. Have I got enough information to calculate the area of the triangle? Yes, I've got my SAS in terms of I've got the side, the angle, and then the side. So I would just use the sine rule to work out the area of the triangle, which is area equals a half. In this case, yeah, it is AB. No, it is, in this case, it is BC sine A. So the area which was given to us is there. So that's going to be X plus Y multiplied by root 3 equals. The value of X and Y are for B and C. So it is a half times X times Y. I'm using the dots for multiplication so that you don't get confused in my X. And then it is times sine of 60. Now, I haven't gone through it today, but you should sort of know, or at least your calculator will know, but it is expected that you can use sine 60, sine 30, sine 90, sine 45, and sine 0, what those values are, because they do sort of create exact values. For sine 60, it is actually equal to root 3 over 2. So if I put in a different color, note, and again, when you put this on your calculator, you can see it, sine 60 equals root 3 over 2. Then we can just use that fact rather than putting it as a decimal. which wouldn't then cancel the root 3 on the other side. It's going to make it a lot easier for us to get the shown value. So we've got x plus y root 3 equals a half xy, and then it is root 3 over 2. If you you can see now that the 2's on fraction to multiply together are going to give me 4. And then if I move the root 3 over to the other side, I can actually cancel the root 3 because it's both there. Root 3 will move over and become a divide. As I've got the 4 there, they multiply together and I bring them up over the other side. So it goes from divide to times. So you've got 4x plus y equals xy. Having a quick look at the format that it wants it in. Okay, I haven't got quite there. I haven't expanded the brackets. I know it's a little bit picky, but it's asked for that format, so make sure you do put it in that format, or you could potentially lose that last mark. So it's 4x plus 4y equals xy. I always like to put a QED to show that's proven, so it's like a mini conclusion without having to write anything else. We've done that part, now let's go on to the second part. When the vertices of the triangle are placed in the circumference of a circle, AC is the diameter of that circle. Determine the value of x and y. Okay, so this has been put into a circle. If I sketch the triangle around, best sketch in the world, but you get to see the general idea. We're told that AC is equal to the diameter. What I'm hoping is at point B, you can remember your circle theorems, and the diameter, when that sort of third point touches the circumference, then it makes a 90-degree angle. So if I was to sort of turn it on its side, I've got this triangle here at 90 degrees. I've got AC here. I've got AB as X, and I've got AC as Y, and I've got the angle there, which is 60. Again, if this is a right angle triangle, I can use SOHCAHTOA. I've got the adjacent at X, the adjacent, and I've got the hypotenuse. So we can use cos 60 equals the opposite, sorry, the adjacent over the hypotenuse, which is X over Y. And again, if you sort of look up on your calculator, you can see that cos 60 is another one of those. So it's cos, tan, and sine of 0, 30, 60, 45, and 90 are the ones that sort of would be recognized for you to be able to sort of write as a nice or exact number. So if we have a look at cos 60 is equal to a half. There's another one to sort of make a note of, remember, but as you said, your calculator is going to be doing most of this for you. So I can now say that 1 over 2 is equal to X over Y. Rearranging this, I get Y equals 2X. So I've got simultaneous equations. I've got this one here, and I've got the one that they have given me. So, and I've got to put another page in, so I'm going to have to fit it in this little gap here. How I would do this is via substitution. You've got y equals to 2x, so I would replace y into the original part A function with 2x. 4x plus 4 times 2x equals x times 2x. On this side, we have 4x plus 8x, which is 12x. On the other side, we have 2x squared. If I divide everything by 2x, I would end up with x equal to 6. I could sort of factorize it because I wanted that. If this wasn't this type of question where I wanted a numerical answer, if I was to factorize it, it would be 2 roots. So the actual graph of this would be cut the 0 and at 6, because you would factorize to take out x. Either x is equal to 0 or 2x minus 12 is equal to 0, and then you'd work through. But I'm taking a shortcut because I only actually want that value of x equal to 6. Substitute that back into the original so that y equals 2 times 6, and I get an answer for 12. So x is equal to 6 and y is equal to 12. Okay, I hope that's helped with the sort of the different ways in which they can use the sine and cosine rule. Now we're going to move on to that new element that I was telling you about. For that new element, you're either going to be using solving equations using trig, or you are going to be doing using trig identities. You are going to be saying that the left-hand side is equal to the right-hand side. This one is a solving equation. Okay, so we have 4 cos theta minus 1 is equal to 2 sine theta tan theta. Now, it's 4 marks, and I have to show that it can be written in that form. If, for whatever reason, you can't find it written in that form, okay, then what you should be able to see is in part B, okay, the reason why this is a show me, if you can't remember the skill of using the trig identities to go from this one here to this one here, then rather than penalizing you twice, you can use that part for part B so that you can work it out. But let's do part A first of all. So 4 cos theta minus 1 is equal to 2 sine theta over tan theta. There's only 2 bits of information that you know. First one is that tan is equal to sine over cos, and anything involving sort of cos squared plus sine squared is equal to 1. There's no sine squareds or cos squareds there. I've got a tan. So I would then write this as 4 cos theta minus 1 equals 2 sine theta times sine theta over cos theta. By writing that identity down, you've probably gained 1 mark. Now, if you move the cos theta over to the other side, we'll go to times, and if you times the 2 sines together, you're going to have cos theta, 4 cos theta minus 1 equals 2 sine squared theta, which will give you 4 cos squared theta minus cos theta equals 2 sine squared theta. A little trick. Deciding on which one am I going to replace it in next. So you're either going to replace cos squared with 1 minus sine squared, or you're going to replace sine squared with 1 minus cos squared. This bit here hasn't got a power on it. I can't do anything with cos theta at AS. When it comes to A2, there are things that can be done, but at AS, I can't do anything. So you're looking at that being a cos theta, can't be done, so I'm going to have to manipulate the sine squared. In doing so, you're going to end up with 4 cos squared theta minus cos theta equals 2, 1 minus cos squared theta. Expand that, give us 2 minus 2 cos squared theta. Move it over to the other side, is going to give you 6 cos squared theta minus cos theta, and that's going to be minus 2 equal to 0, which is exactly what I wanted. So I'm going to put a QED there. Again, it's just something to sort of make sure, there you go, that's proven. I can move on to the next bit. Notice here that whereas there was theta here, it is now 3x. That makes no difference until you sort of come to solving it. And also, I'd like you to notice that that is equal to 0 to 90. I'll sort of move on with that part in a second. So we have 4 cos 3x minus 1 is equal to 2 sine 3x tan 3x. This here is exactly the same as the one above. The only difference, instead of theta is equal to 3x. Numerous times I've seen students then think for B, they have to rework it. That little word there, hence, should sort of show you or remind you that what you've done in A is going to be relevant and also pertinent for you to sort of finish off in B. So rather than going through everything we've just done, I can now write, I need to solve 6 cos squared 3x minus cos 3x minus 2 equal to 0. So I've got myself a quadratic. Now with that quadratic, there are various ways in which you can solve it. I'm going to write it as m squared minus m minus 2 equal to 0, where I would probably tell whoever is marking it this is cos 3x. You could use the quadratic formula. It hasn't sort of specified up here that you have to sort of solve it a different way. You could use completing the square and then solve it, or you could factorize it. How you do it is not important. However, if you don't show a method, so if you just stick that into the calculator and it spits out the answers and put them down, you wouldn't get the marks. There's a method mark for solving these three-term quadratics, and if you don't do it, then you will not get the full marks for it. This can be factorized by 3m minus 2 and by 2m plus 1 equal to 0. Split in the 6m, 3m times 2m is 6m squared, minus 2 times 1 gives you the minus 2, and then that's going to give you plus 3m and minus 4m, which will give you the minus m in the middle. If I then sort of just write down how this would look, so that is three cos 3x minus 2 equal to 0, 3 cos 3x equals 2, cos 3x equals 2/3, and then on the other side, as you can see, is going to be 2 cos 3x equal to minus 1, so cos 3x equal to minus a half. First thing I always do is make sure that if it's a cos or a sine, that it is between 1 and minus 1. If it's outside of those range, then you know that it's impossible, because a sine and a cos only goes up above and below. Sorry, above doesn't go above 1, doesn't go below minus 1. So we're good there. The other thing I do, because this is 3x, I would multiply this by 3, so that I know that I have to find everything between 3x, 90, 180, 270, and 270. Then I find out what the answers are. So 3x equals cos to the minus 1 of 2/3, which is 48.2. And then for this one, I would do cos to the minus 1 of minus a half, which is, so that's 3x equal. Sorry, squashing, I should put another slide in this one. That is equal to 120. Again, I'm going to draw a cos graph or sketch it. It doesn't have to be amazing. It just needs to sort of have all the relevant information. If I deal with cos 3x equals cos to the minus 1 of 2/3, 2/3 is going to be above the line. So it's going to go there, and then the next place it's going to join is here, which is outside my range of 230, because this is 90, 180, 270, and then it would be sort of the 260. So this is the only value for this. So I'm going to divide this by 3, so that x equals 16.07. And that one's done. On the other sort of part, or the other arm of it, if I do it in green, I've got minus a half, which goes underneath here like so. So I've got two potential values, 120. Now, whereas with the sine graph, we were looking at where it crosses the axes. For the cos graph, we look at the peak. There's where the peak is. The next peak is up here at 360. So this would be 360 minus 120, which is equal to 240. So my two potential values are 3x cos of 3x could equal, or 3x could equal 120, or it could equal to 240. If I divide everything by 3, x is equal to 40, and it's also equal to 80. So my three answers are x equal to 40, x equal to 80, and x equal to 16.07. Notice I found out the angles first from the graph before dividing it by 3. Again, a common mistake would be to do 48.2 divided by 3 and then use the 16.07 to work out where the other places are. You always find out where the angles on the graph are first, and then you divide for the next part. Okay, we've got another one. I might skip a couple of questions only because we've got a good 10 minutes, we'll see. So the next one is show the graph of, let me see, that's it, sorry. Yes, right. These three lines here, if you can see them, they mean they're equivalent. So show that 10 sine squared theta minus 7 cos theta plus 2 over 3 plus 2 cos theta is equivalent to 4 minus 5 cos theta. So you don't use the right-hand side. You just use everything on the left-hand side to work out what you can do. And then from that, you would then show that it equals the right-hand side. And again, you only know two things. So it's either going to be involving a tan, or you're going to be replacing either a sine squared or a cos squared. Well, if you look at the right-hand side, we need it in terms of cos. And then as far as I'm concerned, I'm not going to look at it until I get closer to the end. So that sine squared theta there, I'm going to have to replace that straight away. So that's going to be 10, 10, and then 1 minus cos squared theta minus 7 cos theta plus 2, and that's all over 3 plus 2 cos theta. If I was to expand that now, I would get 10 minus 10 cos squared theta minus 7 cos theta plus 2. I know it's over 3 plus 2 cos theta, so I'm just going to work with the top line for the moment, just because I need the space. Cos squared theta, that's going to be minus 7 cos theta, and then that is going to be plus 12. The only way I can sort of see me getting rid of the bottom part of it, because I can't move it over to the other side and sort of expand it, the only way is if I can factorize this. Now this is minus 10 cos squared theta minus 7 cos theta plus 12. You're not going to be able to use the quadratic formula for it because that'll give you the answer, so I need to factorize it. Therefore, one of the cos, so if I put I don't know, cos theta equals, let's leave it as m again, so I can then say that that's minus 10m squared minus 7m plus 12, and that can be factorized with a double bracket. I'm going to have to do it as, so it's going to be minus 5m and m, and then the 12, so I need to get minus 7 in the middle, is going to be 4 and a 3. There's going to be minus 15. That's going to be a plus there. And then, so it's minus 15m and then plus 4m. I've got the 2 there. Plus 8m. And that will give me the middle bit of minus 7m. So I have got, if I then rewrite it in 1, minus 5 cos theta plus 4. 2 cos theta plus 3 over 3 plus 2 cos theta. And I know they put a theta there, so it's fine. Notice that this will cancel with this because it is multiplied on top. So I have 4 minus 5 cos theta, which, looking where I got, it's in the right form, QED, and then move on to part B. Hence or otherwise solve for the equation. Okay, so we have then this we've just been working with. It's exactly the same. So I can just put in 4 minus 5 cos theta equals 4 plus 3 sine. I know they put x, I'll put it on the next one. Theta. The 4s will cancel away with each other. So I am left with 3 sine x equals minus 5 cos x. There's no squares there, so I can't do anything with that. So what I will do is, if I bring the cos underneath the sine, and if I take the 3 over to the other side and bring it underneath the minus 5, I have sine x over cos x equals minus 5 over 3, or I have tan x equals minus 5 over 3. X equals tan to the minus 1 of minus 5 over 3, which is equal to minus 59. Again, let's have a look where it wants it between 0 and 360. If I do a quick sketch of a tan graph, asymptotes at 90. Sorry, asymptotes at 90 and minus 90. This comes down and goes there. 180 is there. Asymptotes at 270. And that's going to be 360. So the graph looks Not a great one, but again, it's just a sketch. So I don't like that too much at all. So then the graph will come down and go like so. So I've now got minus 5/3 is looking there. So I've got 3 potential places for it. So I'll be looking at, for a sine and a tan graph, I always look at where it crosses the axes. So this one, the distance from here to here is 59. So from here to here is 59, and from here to here is also 59 because you use the symmetry of the graph. So x equals 180 minus 59, and it also equals 360 minus 59. So my 2 answers are 121 and 301. You can check this by putting tan of 121 into your calculator, and minus 5/3 is the same as 1 2/3, which is minus 1.6 recurring. You won't get exactly minus 1.6 recurring, but it should be to 1 or 2 decimal places, so it should be at least minus 1.6. And I think I checked it before, it was minus 1.66. Moving on to the next one. Is that a repeat? Sorry. Yes, that's a repeat. I thought I deleted that one. I do apologize. Moving on to the next one, we have sine squared minus cos squared over 1 minus. I think I got about enough time to do this one, and then the other ones I'll upload. And if you want me to, I can I'll finish them off, and then I'll upload them so you can go through the other questions in the resources part. So again, you've got your 3 lines, so you have to show that sine squared minus cos squared is over 1 minus sine squared is equivalent to tan squared x minus 1. First thing I would do is notice that is cos squared. So we have sine squared x minus cos squared x over, instead of 1 minus sine squared, I'm going to write down cos squared x. In doing so, we can split the top equation. So that's going to be sine squared x over cos squared x minus cos squared x over cos squared x. So we get tan squared x minus 1. Again, QED. Nice 2 marks. Using the knowledge of 1 minus sine squared x equals cos x, and also sine over cos is equal to tan. In this case, sine squared x over cos squared x equals tan squared. Again, hence that word. So I'm going to look part 1. I'll look, it's exactly the same. So instead of writing sine squared x minus cos squared x, blah, 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 I would write tan squared x minus 1 equals 5 minus tan x. Rearranging this, you get tan squared x plus tan x, the minus 6 equal to 0 because the 5 comes over as well. If I put tan equals t, tan x equals t, and then I can put this straight in. And as I said, if you are finding it difficult to factorize, obviously you need to practice that, but you can use a quadratic formula when it is equal to. If you have to use the identities to go from one side to the other and you have to factorize, you're gonna struggle with it. But for this purposes, you could use a quadratic formula. You've got tan, so you got the 2 t's there, and minus 3, and I want a plus 1, so it's going to be minus 2 and plus 3. So tan x equals, tan x minus 2 is equal to 0. Tan x is equal to 2. Tan x plus 3 equals 0. Tan x equals minus 3. X equals tan to the minus 1 of 2. And x equals tan to the minus 1 of minus 3. Sorry, x equals, what do I get? 63.4, or x is equal to minus 71.6. Again, tan graph. Asymptote, round, so that's at 90, minus 90. Asymptote at 270, 180, and then that's at 360. That comes down. So for 2, there are two potential places. So this one is going to be 180 plus 63.4, which gives me 243.4. And then for the other ones, it is going to be 180 minus 71.6 and 360 minus. So it's going to be 180 minus 71.6, which is 108.4. And then 360 minus 71.6, which is 288.4. So the answers that they would expect to see would be this one, this one, this one, and this one. So there are 4 answers, which is why it's worth this sort of 6 marks. I am aware that I've got a couple other questions, but it has finished at 6 o'clock. So what I'll do is I will go through those other remaining questions, excuse me, and I will sort of fill in, but you won't see them on the video, but they would be on the actual resource itself, so that you could, I don't know, have a look at what the question is, try it yourself, and then go from there. Thank you very much for your time, and I hope it's been helpful. I'll see you next Tuesday. Thank you very much. Sorry, next Wednesday, same time. Thank you very much.